In this example, we're going to make a system of a quadratic and linear, a system that includes a quadratic and a linear. And first thing we want to notice is that the quadratic here is in standard form and it has a negative a value. So immediately my brain says I have to have a sad face parabola. Now that's going to all be taken care of by the two steps to move my green and blue dot. My green dot needs to be my vertex. The vertex of a parabola is always represented as h comma k. And we have our excellent formula for h, the x value of the vertex, is negative b over 2a. And then the k value happens by plugging in the h to the quadratic function. So we've got two parts, find the h, and then plug it in to our quadratic expression. So first thing we want to do is identify up here in our quadratic that the -1 is a, the -6 is b, and the -1 is c. So let's work to find the green dot. We do negative b, so -6 divided by 2 times the a value, which is -1. So we got to be very careful. We got lots of negative signs happening. So I'm going to multiply the negative times the negative on the top, and that'll get me a +6 divided by -2. If I reduce, that'll get me -3. So I have now h is -3. Then I have to find k. I find k by substituting the -3 into the original quadratic expression right here. So I'm going to write parentheses. There's a negative on the outside, -3 on the inside squared minus 6 times -3 minus 1. And then we're going to go ahead and plug that directly into our calculator, or we could work it out by hand. So if I work it out by hand, I should get -3 squared is +9 times the -1 is now -9. And then I should get -6 times -3, which give me a +18. If I combine that, that's going to give me 9. Minus 1 is going to give me 8. So my k value should be 8. So again, you can plug that all in your calculator once and get 8, or work it out like I just did, and so that my coordinate for the vertex is -3, 8. So that's going to be where I put the green dot. And then every time the blue dot, we want to just go ahead and make become the y-intercept. The y-intercept, if you're in standard form for a quadratic, is always equal to the c value. So all we have to do is just call the green dot, or sorry, the blue dot, whatever the c value is. So since the c value here is -1, we're going to connect it at -1. So let's go ahead and move our two dots on this screen. So the green dot goes to -3, 8. And then we grab the blue dot and just drag it right on down to -1. And then the graph is now a sad face parabola, as I said it was going to be at the beginning, and it's in the right location. So that was how we put the quadratic in the right place. The next thing we need to do is now plot the line and make the graph of the system complete, and then we will identify our solutions. So let's go ahead and look at the line. The line is not in the form we typically like it to be in. Right now it is in standard form for a line. What we could do is use the standard form of the line the way it's meant to be used, which is to identify x-intercepts, or we could just subtract this 2x to the right and use slope-intercept form. Either way works. If we want to find intercepts, the way that works is you cross out or plug in a 0 for the x, and that'll get me the y-intercept. The y-intercept is 2. And then I just go back a step, erase that part, and then I can cross out the y or plug in a 0 for y, and that'll find me the x-intercept. If I solve for this x right here, divide by 2 from both sides, I get x equals 1. my x-intercept will be 1. Now I'm just going to leave those there just as a refresher from Math 1 that was a possibility. If you plug in a 0 for y, then I found 1, 0. When I plugged in a 0 for the x, I found 0, 2. So that's how you find an x and a y-intercept, by plugging in 0 for their corresponding variables. And now what I'm going to do is do it the other way, which is solve for y and put it in slope-intercept form, because I want you to be flexible, whatever is most comfortable for you. So I'm going to just subtract 2x from both sides. And I'm not going to make a mistake and actually mess with the 2 and the negative 2x. I just rewrite it. So this will rewrite to be negative 2x plus 2 equals y. So now it's in slope-intercept form, the way we're usually most comfortable with. And so the slope-intercept form would be you plot the 2, the positive 2, and then you'd use slope. You would count rise down 1, 2, and you would run to the right 1. And sure enough, my x-intercept and my y-intercept were in the right location, and I have now graphed this system of a quadratic and linear function. Next step is to identify how many solutions we have. Well, it crosses in 2 locations, so I have 2 solutions, and then my job will be to name them. I see the first one is at the vertex, so I already know what the vertex is. Vertex was negative 3, 8. Make sure I put this in parentheses, or it's just random nonsense. Negative 3, 8, close parentheses. And the second coordinate of intersection is negative 1, 4. So open parentheses, negative 1, 4. And then I submit that, and I have successfully solved the system by identifying the 2 locations where it intersects. And again, from the beginning, when it asked for what are all the points in the solution set, it means where or how many points of intersection do you have. And now we have completed the process.